Okay guys, today we're going to go ahead and talk about dividing rational expressions. It's pretty much the same as our multiplying. The only difference is I'm going to actually flip the second fraction and change that division into multiplication. So as long as that's the first thing I do, boom, it's just yesterday's idea. So like I said, leave the first one the same. Turn that into multiplication and flip your fraction. Now we're doing the same idea that we did yesterday. Now, if you notice, these are slightly more complex. We're going to identify whether or not it can be divided out of every term. If so, makes my life easy. If not, then we have to go ahead and do our t factoring. So if I look, I've got 5, 10, and 15, both simply easily divisible by 5. So we're going to start by doing that. So I'm left with x squared plus 10 divided by 5 is 2, and then minus 3. From there, I can leave my 5 out front and have two sets of parentheses, x and x. Multiplies to negative 3 adds to 2. Well, that's going to give me a positive 3 and a minus 1. So that's my first, and I'm going to actually move that. I realize that it leaves, oof, that's not what I was going to move. Leaves me no room to continue writing with. Move him over here. We're going to do the work over on the side. Sounds great. I identify that my denominator can just go ahead and go straight to the two sets of parentheses on that left one. So x and x multiplies to 5, adds to negative 6, so they both must be negative. And that's going to have to be a 5 and a 1. Now we're looking at the next numerator, and I see 4, 8, and negative 5. Well, shoot. Those, unfortunately, are not all divisible by 4, so I have to do my t. So on top is 4 times negative 5, which is negative 20. And I need to add to 8. So I've got 10 and 2. Well, 10 and 2 can get me to 8. I need a negative 10 and a positive 2. So I have 4x squared minus 10x plus 2x minus 5. I could take a 2x out of both, and I'm left with 2x minus 5. Leave a little space, 2x minus 5. I see it repeats, so just plus 1. So I get 2x minus 5 and 2x plus 1. Oof, getting real close to the edge there. I think we're going to scooch it all over just a smidge. All right, let's take a peek at this bottom. I've got 2, 7, and 3. Yep, definitely not divisible by 2. So we're, again, t factoring. So 2 times 3 gives me 6. So I need to multiply to 6, add to 7. That's just going to be a 6 and 1. So I have 2x squared plus 6x plus x plus 3. I can take out a 2x, and I'm left with x plus 3. Leave a little space, x plus 3. Again, repeats, so just plus 1. So I have 2x plus 1 times 2x plus 1, x plus 3, there we go. Sorry, I lost track of where it was. It's like, where did it go? So we're going to go ahead and start canceling things out of the blue. Not physically out of the blue, but in the blue writing. Sorry, I realize that's a colloquialism. And we're going to use pink to do it, so that way we can distinguish that it's different than what I've already done. I've got a factor of x plus 3 on both. I've got x minus 1s. I have 2x plus 1. And I believe that's all I have left. So, scroll down so I'm not writing on my face. I have 5 times 2x minus 5 on the numerator, and x minus 5 left on the denominator. And then we got to talk about my restrictions. X cannot be 5, 1, negative a half, and negative 3. All right, number 2. Okay, so 4 is my last one. Just wanted to make sure that I have you guys practice one on your own. I'm going to put it back in the middle. Now I'm going to leave it back over here. All right, so we're going to leave the first one the same, x squared minus x minus 12. That's not a lambda, I want an x. Lambda is a Greek letter, in case you're curious. So 8x squared on top over x squared minus 16. And I look to see, okay, none of the guys have numbers in front, and those that do have no other terms. So I can go ahead and go straight into my parentheses. So the ones that didn't get parentheses, they're not going to change. X and x, okay, what goes to 12 adds to negative 1, so negative 4 and 3. This is the difference of perfect squares, so x minus 4 and x plus 4. Okay, I have a factor of x minus 4. I have an x squared and an x squared, and then I can take 8 divided by 2, which leaves me with 4. So I have 4 times x plus 3 over x plus 4. X cannot be equal to 0 causes here, 4 here, and negative 4 here. What does 4 look like? Okay, I want you to, we'll start this one and then I want you to pause, come back and check your answers. So we're going to keep the first guy the same. And then we flip the second one. Ooh, I have a hint. This might be a perfect. Difference of perfect squares. Ooh, 54, not 45. All right, so we started it. Pause it, come back, check. Ooh, 13. Okay. Sorry, 78 outside my head. Nope, was not happening. Hello, come on. So I get x times x minus 13 all over x plus 6 quantity squared, and x cannot be equal to negative 13, negative 6, or 9. All right, last one we're going to do. We're going to go ahead and start by rewriting it. So x squared minus 4 over 9x minus 3 times 3x squared minus x and 2 minus x. Now I'm going to even go a step further and I'm going to rewrite that right now. of negative x plus 2. Remember, I always want x to come first, and I want them to be positive. So hint, 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 maybe we're going to take out a negative 1. And we're going to pause our video and come back, guys.